All right, it's the same thing we just finished doing, okay? But I want to add a little bit to it. This proof doesn't have it on there, but let's just say that it didn't ask you to prove these triangles congruent to each other. I'll just erase them. What if it asked you, it gave you the same information, but it asked you to prove that FG was equal to IH? Oops, it's not much of an H, is it? I meant to do that, IH. Okay? How'd you know that? Did you learn that somewhere else? Did you? Okay. Did you take geometry last year?
It was kind of, well...
It's like an integrated thing?
Yeah.
Okay. Alright, so anyway, let's look at this. So FG equals IH. That's what I want to prove. I want to prove that this segment is equal to this segment. Let's go back. We already know that this triangle is congruent to this one. Agreed? If two triangles are congruent to each other, look, I know that this side is equal to this one, this side's equal to this angle is equal to this, but what about this? Let's go different color. Let's go this, I don't know, can you see that light green? I don't know. What do you think must be true about angle F? Can you see that?
Yeah.
Yeah. What's true about this angle F, do you think? Remember, this triangle's we've just proved that this triangle is congruent to this. That's right. Would you agree? Because the corresponding sides and angles have to match up. Remember, I take one triangle, stick it on top of the other one. All the stuff must be true. I've only shown that these two sides and this one pair of angles are congruent to each other, right?
Right.
But now that I proved the triangle is congruent, what must automatically be true then? This angle and this angle must be equal. What else?
The other angle.
This angle and this angle must be equal. And what else?
The thingy is equal.
Right. This little segment and
That one.
this little segment right here have got to be equal. Would you agree? It wasn't in the given. They never told you. But what did you just do? You proved the triangle's congruent. That means all the other stuff we didn't talk about have got to be equal as well.
So it's angle side angle.
Does that make sense? Okay. Nope. Right. I'll show you what it is. These are all corresponding angles, right? This angle corresponds to this one to this one. This side corresponds to this side. You may not remember, but I do remember telling you this because I knew I was going to get to this point right now. I said that these were all called corresponding, not just sides and angles, but corresponding parts. Do you remember that? Okay, they're all corresponding parts. You've got angles and sides that are parts. They're corresponding parts of what's true about these triangles right here. Of congruent, what? Triangles. Now, what must be true about F and I and this angle right here and this angle right here? If they're corresponding parts and you've got congruent triangles, what must be true about angle F and angle I? They must be congruent as well. That's right. So, corresponding parts of congruent triangles are congruent or equal. I taught out of a book that said equal instead of congruent. Now watch. That's a nice little short way to do it, but we got a better short way to do it. And Chris has said it about 5 times already because he's learned it at his other school. Where'd you go to school before? At Gunning Bedford they taught you this?
No, it's integrated math.
Oh, it's
So
integrated.
A little bit of algebra, a little bit
Right.
of geometry.
Yep. Yeah, so integrated math, they kind of mix it up a little bit. So he's already learned a little bit of this geometry already. So watch, it's corresponding parts of congruent triangles are congruent. That's the shortcut way of writing this, okay? But look what it stands for. This first C is correspond. A lot of C's in here, right? The first C is corresponding parts. We don't have anything for the of, but of what? Congruent triangles are congruent, okay? First C is corresponding. The other two C's are congruent. And that's our reason. So watch. If I wanted to prove that FG was equal to IH, I have to prove the triangle's congruent first. Well, I've already done that, haven't I? I proved the triangle's congruent. Now I can say that FG equals IH. And what's my reason for that? Why do I keep doing that? I keep thinking of the I like this. Okay, so FG is equal to IH. What's my reason? CPC TC. Now, if I was to say it, I would say, just to shorthand it and say it, I would just say, because corresponding parts are congruent. All right? So if I ask you, I was like, why are these two segments equal to each other? You would just tell me, because corresponding parts are congruent. Or you could just say, because they're corresponding parts. If you want to say that, fine. You don't have to say CPCTC. All right? But you write it like that. Everybody with me?
Yeah.
I could put another. I could have said, instead of prove that this was equal, I could have said, prove what? That angle F was equal to what? Angle I. So what would you do? Your step would be angle F equals angle I for what reason? Yeah, because of corresponding parts, right? Because of corresponding parts, or CPCTC. Make sense? I could have said this. Give me a second. I could have asked you this. I could have said, all right, prove that angle FGD was equal to angle what? IHD. IHD. So I could have put that in here. What would be my reason for that? Corresponding parts. Does that make sense? All right. So you may see some proofs that don't necessarily ask you to prove the triangle's congruent. They might just ask to prove that this segment is equal to this segment. But what do you have to do in order to get them equal to each other? You got to prove the triangle's congruent first, even though they don't tell you to do it. You got to prove the triangle's congruent first. Once the triangles are proven congruent, then all the other parts that match up, that are corresponding, are now going to be equal to each other. Makes sense, doesn't it?
Yeah.
Okay. Who had a question? Okay.
What if you wrote, like, you know how you said you write CPCT, but you don't say it like that?
Yep.
What if you wrote corresponding parts and whatever? Think about it.
Write this?
Yeah.
You can write that if you want to, but why would you bother to do
I
that?
don't know.
I would rather write this, don't you? Yeah, you can write that. It wouldn't be wrong. Definitely wouldn't be wrong if you want to write that out. But I would write CPCTC. I think it's a lot easier, quicker, right? Yep. All right. Now watch. Here's another crazy thing. QED. What's that mean?
Qued.
Qued. That's what somebody in my other class last year, they'd always say qued all the time. Ryan Kingshill. Ask Ryan Kingshill about qued. He would say it every time. It's a little silly thing. In college, I don't know what class it was, but they taught us this. It's Latin. I don't know any Latin at all, but it's quid est. I think it's S or something like that. Es. Quid est demonstrantem, which means like something like as was demonstrated. So if somebody really knows Latin, I probably butchered it, but it's something close to that. Okay, quid est demonstrantem, as was demonstrated. It's kind of like somebody putting their stamp of approval on it. Like, all right, I did this proof, I went through all that work, bang, I'm done. That's it. The end. Kind of like the end at a movie, you know. It's like, boom, we're done. So that's kind of like a proof version of, all right, I'm done. That's it. You know, kind of thing. You don't have to put that on there. You see that again. One of my times that I was looking at some geometry stuff, I actually saw one of the teachers actually did that at the bottom of his proof. I thought that was kind of interesting because I had never seen anybody do that since I was in college, and it was kind of funny that somebody actually did that. You can look it up if you want to online. Google it, QED or quid, you know, and you can see what's going on there. All right, you don't have to do that. Just thought I'd show it to you. It's just kind of a weird, silly thing to do. All right, that's it. I'm going to give you a few problems here to work on, and I'm going to give you, let's see, tomorrow I'm going to give you a worksheet. Actually, a couple worksheets, so that you stay nice and busy for the substitute. But today you're going to do this. You're going to work from the book. It's page 268 and 269. And it's just four. It's four proofs, okay? But it's 14 and 15 and 24 and 25. Section 4.4, page 268, 269, 14, 15, 24, 25. Now, we're not going to be able to go over them tomorrow because I'm not going to be here, but I'm trying to have it finished. I'll collect it on Monday. All right, we'll go over a couple of these proofs on Monday, but then we need to move on, all right? Because we got to learn some more reasons. There are more than just the two reasons to show that triangles are congruent to each other. So we're going to hit some more of those. We're going to do some of the same style of proofs, but then we're going to have all kinds of reasons. We'll have side, side, side. We'll have side, angle, side, and we'll have about 3 or 4 other ones that we can use, all right, to prove that triangles are congruent. All right, everybody got that? All right. Okay, that's it. Everybody say bye.